Hi everybody, I'm Tadej and I'm the CTO of Apilon. And as the title says, today I'm going to be talking about decentralized applications and how unstoppable they are. Now, I specifically am saying unstoppable because I believe decentralization is just, a means to an end, and the end is unstoppability. So the ability for application, to not be censored by government or any other kind of institution, and for it to be open and free. Now, since all of you are here at Web3 Summit, I believe that answering the question why application should be unstoppable is, is something that you should all have cleared by now. If not, there are a lot of good keynote talks from yesterday that you should check out. Okay, let's start. In practice, I want to look at UnisSwap because, first of all, I hope all of you know what UnisSwap is. If not, it's a decentralized exchange. And secondly, I believe they're one of the more unstoppable apps out there. They're really trying their thing. They're not the most, but I think it's a good example to look at. So let's check how they do their tech stack. First of all of their essential code is written inside smart contracts. And those smart contracts are deployed on blockchain, so are accessible to everyone and essentially unstoppable. That is, if the smart contracts are written in a way that there's no owner control that someone could stop them. But today I'm going to look more at the technological possibilities, how we can make them unstoppable. Now, the application of this is still up to the user and for the consumer to double check and verify. Now, even if everything is on smart contracts, that extremely limits the amount of users they can have because you need to know how to directly interact with those smart contracts. So, of course, you need a nice user experience, a nice front end. And that's another vector of unstoppability. Now, UnisSwap has their front end served via Cloudflare, which is a centralized provider. But they're also deployed on IPFS, which is a distributed file system where the front end or the page is located all over the world across and can be fetched from anywhere. Now, they're doing a compromise here, and I believe it's a good compromise. They're using a centralized provider for speed, for cache, but they're also thinking ahead. If something happens and Cloudflare shuts them down, you can still find them directly through IPFS. And each time they do a new version, all the IPFS information is published and available on their GitHub. Now, the next thing they do is, when you're using UnisSwap, you need to know what kind of tokens you can swap, and that those token lists are also available and hosted on IPFS and served via IPFS gateways. Gateways are, again, a bit centralized because they fetch data from IPFS, which is a protocol, and make it available through HTTP. But those can be swapped out very, very seamlessly. So these things are, let's say, does not hinder the unstoppability. It's just more of an inconvenience if something is stopped. But sooner or later, people will figure it out and they can use it directly through IPFS. Now, the next thing is a bit more interesting. So if you're doing a swap, let's say from token A to token C, and there's no direct pair, you actually do a swap from token A to token B and from token B to token C. And calculating that to get the best route, where the least slippage is, the best fees, is not so simple and requires quite a bit more of computational power and data fetching. So for that, they have a Node.js application that's hosted on AWS. Now, this part is, if AWS decides to shut it down, you can't really do much in the case of replacing it, but the code is open source on GitHub, so you can open up your own, set up your own server. Or if you know the exact hops you want to do, you could still do it that way. So it's not stoppable in that way, but it does hinder the usability a bit more. And the way they're connecting to the blockchain and fetching data is via Infura, RPC provider, which is a centralized provider as well. And that's a big deeper problem, but I'll get to that a bit later. But this is, their tech stack so that they're achieving this level of unstoppability. But there are also other things that they do because of that. First of all, there's no database on their side. They only use local storage on your computer. You can't get any email notification. They're not gathering any of this information. They're, like I said before, using AWS for centralized compute power for that part where they don't know how to decentralize it. The website itself has to be static. That is because server-side rendering is not possible with IPFS, since it's just a file storage protocol. And like I mentioned before, they're using multiple providers to achieve the current level of unstoppability. So they're using Cloudflare, Pinata, Infura. At some point, maybe still, they were also using Crust and Filecoin for the decentralized spinning on IPFS. So a lot of things that they need to do to achieve this, and they're really doing their job. But they're, I would say, more of an exception than a rule. Most decentralized applications stop at smart contracts. And I'll see this as a more philosophical slide of the question, why is that? You here are probably users of decentralized applications, builders of them. I'm not sure how you do it, but maybe there's something you should think about. Like, is it just too much work to do that? Too complicated? Does it hinder user experience? Maybe the end user just don't care. Or there's just no technological solution, or it's too limiting, and you don't do it because of that. Now, unfortunately, even though I'm here talking about it, I don't really have all the answers to this. But what we do at Apelon is research tons of different projects that do try to solve parts of this. And I want to go and show you a few of them and what they're doing and how they could help your apps become more unstoppable. But before that, I want to give a few caveats. First of all, this is research I did, so please do your own research of these protocols. Second, these are not all the protocols that exist out there, are just the ones that I researched. And of course, the opinions I'm going to give about them are my own, so do your research once again. Okay, let's start. First, I want to look at decentralized compute power. Here I want to look at Phala, Akash, and Acorist. Now, what all three of them have in common is how they're matching providers of compute power and the ones that need them. They have a peer-to-peer marketplace, their own token that connect them together. But that's usually where things stop in comparison. First, Phala, you can run Inc code, so Rust, and you can even do some JavaScript. And they're very good at connecting their decentralized compute power with smart contracts directly. So it's very useful for creating oracles. And I heard some whispers that some more powerful JavaScript worker or APIs will be possible in the future. The code is run in a trusted execution environment inside a computer's CPU, so it's very safe, private. It's end-to-end encrypted. You have even some encrypted storage that you can do. The environment variables are encrypted. And they have automatic redundancy if one of the providers fails. But they have quite a bit of, at least currently, quite a bit of limitations of the speed and size of the code that you can run. Akash, on the other hand, is extremely powerful. You can run any kind of Docker image. You have full resources of the computer, all the CPU power, all the RAM, the storage, but it's not run in trusted execution environment. So the provider of this compute power could tinker with the code that you want to run, which in my opinion is quite a bit of a security issue. They also don't have encrypted environments. So anything like a private key stored anywhere to create a transaction is a big no-no. Then we have Acurast, where you can run JavaScript code and even some Node.js environment. It's run on mobile devices and in a trusted execution environment. And this is actually quite interesting because mobile phones are actually extremely powerful. They have multiple gigabytes of RAM, multiple processors, and are quite powerful. And if you, I don't know, break your screen, break your camera, basically for a normal user, that phone becomes useless and you can buy it for $10 somewhere on eBay. But it can be repurposed and reused as a computing power. They currently don't have any redundancy if one of the phones that you try to run on fails. But from what I hear, that's gonna be fixed soon as well. And communicating with the phones is done through their SDK and WebSocket. So it's not really like an API, but you can put that thing on top and do it yourself. Now, even with this, you could solve a bit of the UnisSwap part of computing power. But let's explore technology further. Let's look at decentralized databases. So this is a bit different than the compute power, because the compute power is you have your backend now and you can just use it the same way in a decentralized manner or unstoppable manner. But with databases, the data, which is, if they're decentralized, the data is usually public. So there's a whole paradigm shift in the thinking that you need to do when you're building a dApp. What kind of data? So basically you want to, if you do it like this, you create a dApp where data is going to be shared and someone else can bring their own logic and bring their own front end and start building on top of it. Of course, some data needs to be encrypted. There's private data of the users that you cannot share and don't want to share. So it's a really different perspective and different way of thinking and building an architecture from the get-go. Now, how these different providers differ between each other is what kind of SQL way they're using beneath, except Ceramic, which is event-based, but they have a Postgre solution on top of them. And let's say with TableLands, how writes and reads are done. So with TableLand, for example, each write is actually a transaction on an existing blockchain. So either on Base, on Polygon, it's a write is a transaction, meaning it's pretty slow and expensive, but reads are free and everyone can do it. Others are more or less their own blockchain or their own thing and have basically differ between each other in different ways of accessing and who can access and how can access their information. Is it either transaction level control or is it like a Gitcoin password or something like that to protect civil attacks, etc. Now I'm not going to go too deep into technologies. Check them out yourself. I want to more give you a reason to think about this architecture part of sharing data. The next thing I want to touch is RPCs and indexers. So like I said before, Infura is a centralized indexer, and there's quite a bit of projects that try to make a decentralized network of indexers, which they control through a load balancer and find which one is available, good, and paid for, so that if one goes down, you have redundancies. These are projects like Subquery, dRPC, and Poct. Smalldot, on the other hand, is a very, very interesting product. It basically creates a node super small and super light that it can run inside the browser. So for the end users interacting with the dApp, they're completely decentralized in that way. But if you're builders, when you're creating dApps, you also want to process sometimes, depending on what you're doing, like large amounts of transaction on your backend or wherever. And in that case, you will still need an RPC provider. And as far as indexing, so this is basically to display data from blockchain to the end user in a nice formatted manner. You fetch data from the blockchain in a central server, save the data, format it, and make it available to the end user. Subscript and subquery are decentralizing that part as well. I only heard about the subquery part later, so I didn't research it that much, but I'll leave that part to you. And the last thing I want to talk about is privacy. Now, you would say that maybe this does not connect to unstoppability directly, but it kind of does. I want to look a bit at Oasis Network, which is a smart contract blockchain that enables end-to-end encryption and all the smart contracts running in trusted execution environment. And one of the features is that they can generate a private key, maybe for Polkadot, for Bitcoin, for Ethereum, whatever it is, inside a smart contract. And you can control the logic about it. So no one knows what that private key is. It's fully encrypted. And you can give access logic to it or any kind of logic around it. So you can even do things like fully decentralized non-custodial wallets. So you have you're solving even this unstoppability issue of like a Coinbase smart wallet where their keys are stored in hardware secure modules somewhere around the world or however, but they still control the access to it, or their data centers can go boom. And you can even do things like trustless bridges, etc., which really help the unstoppability and decentralization of networks. And for the end, I want to encourage all of you to check this different products or protocols that help unstoppability. There are even more out there, of course. Do the research, try to implement them yourself, see if it can help you with creating better, more unstoppable decentralized applications. If you're more on the lazy side, you can also check out Apilon, where we gather and study this technology and try to make them easily accessible and usable from one single platform in an easy manner. Thank you very much.